Hey, welcome to an example of Mr. Wernau Does Your Homework. We're going to take a look at a couple of these real quickly. The first one we're going to take a look at together is number 4 right here. This is on our related rates. An observer is standing 25 feet from the base of a flagpole and watching a flag being lowered at a rate of 5 feet per second. Determine the rate of change at which the angle of elevation, so we want to find d theta dt, from the observer to the flag is changing at the instant the flag is 25 feet. So this is going to be my constant. So I'm just going to call that A. This is going to be B. And we're told that B is just 25 right there. But we're also told how fast B is changing. The flag is being lowered at 5 feet per second. So I know that dB dt is negative 5 feet per second. Remember, it's going to be negative because it's going down. And it's yelling timber. So there's my flag, and it's going down. And we want to find this change in angle. So we want to find d theta dt. And let's see, just for fun, we'll call this C. This is a 45-45 triangle, so that's going to be 25 root 2. You can verify that by using Pythagorean. And I want to find out how fast this angle is changing. So we talked in class, anytime we're looking at an angle, we are going to use a trig function. So here's the biggest hint anybody's ever given me. We want to use this A right here because that's our constant. Now, I could use my cosine equation, but that involves the hypotenuse. I really don't know anything about the hypotenuse other than how long it is. So I'm going to use my tangent function instead. So in tangent, we're going to say the tangent of theta is the opposite, which is B over A. But because A is a constant, I can write this as B over 25. I'm going to keep B a variable because this is going to be changing as we lower the flag. So there's my equation, and I'm going to rewrite this as 1 over 25B. So taking the derivative, well, the derivative of tangent, secant squared theta, be careful, it is a chain rule, d theta dt, and that's going to equal this 1 over 25 dB dt. That's actually kind of nice. So what is secant equal to? Well, I don't have to actually find the angle because secant is the flip of cosine. Recall, secant is just the adjacent over the, well, cosine is the adjacent over the hypotenuse, so we're going to flip it. This is the hypotenuse over the adjacent side. So that's our secant. And our hypotenuse, it is the 25 root 2 over the adjacent, which is 25. Square that, d theta dt equals 1 over 25 dB dt, which is what we're told, that's our negative 5. This cancels, and kind of ran out of room here, so man, post-it note mathematics, there we go, kind of ran out of room there. So I can solve for d theta dt. By squaring this, I get 2 d theta dt equals negative 5 over 25, and I'm just going to divide. So I get d theta dt equals negative 5 over 50, or negative 1/10. We measure radians for degrees, and time here is going to be seconds. So we can say that the angle of elevation is decreasing, because it's negative, decreasing at a rate of 1/10 of a radian per second. And there's our example. Hope you enjoyed it. All right, let's do another one real quick. That was kind of fun. Let's see here. That's our shadow problem. You can take a look at another video on that one. One that's causing some people some trouble. Let's take a look at number 6. We got the length of a rectangle. We're just going to look at part A here real quick together. The length of a rectangle is decreasing at a rate of 2 centimeters per second, while the width is increasing at a rate of 2 centimeters per second. When L is 12 and W is 2, find the rate of change of the area of the rectangle. So the area of a rectangle we know is L times W. So if I take that derivative, dA dt, that's going to become, be careful, normally I can replace these, but here I can't. This is going to be our product rule. So the first, L times dW dt, plus the second W times the derivative of the first, dL dt. And they tell us this. The length is increasing by this much, so there's dl dt. It's decreasing, so it's going to be negative 2, while the width is increasing at this. So we're told dw dt is going to be a positive 2. And we just plug in the equals L and W. We just plug everything in. dA dt, L, which they tell me is 12, dw dt, which is 2, plus W, which is 2, times dl dt, which is negative 2. And that becomes 24 minus 4, or 20 units. We're talking centimeters per second here. That's an area, though, is centimeters squared. Time is measured in seconds. So we're increasing at 20 centimeters squared per second. Hope you guys enjoyed the video. Smash that like button. See you soon.